Hello students, in this video we are going to learn about how to measure angles using theodolite. A theodolite is an instrument where which we use to measure horizontal angle and also the vertical angle. So in the previous videos we have discussed about compass. It is also an instrument where we can find out the angles, but we can able to find out the angles only with reference to the north. Whereas a theodolite, you can measure angles from any point. So the theodolite normally looks like this. It's a cross section of the theodolite. The main parts of it are given in that figure. It has it is fixed to a tripod, and then we have uh, plate bubble. Then we have a tribet. Then we have the standard to that telescope is fixed. From telescope we focus to 2 points and then we can able to find out the angles. We discuss the technical parts in this video and how the angles are also measured. So the main uses of theodolite are to measure horizontal angle, vertical angles, and also we use the theodolite to set out lines and angles. We use the theodolite for the optical distance measurement. We call that thing as a tachymeter. Then we have plumb tall buildings, whether the building is in a to plumb or not. Then we set out railway curves. Then we exactly locate the position of piers by using some angles. Then GPS point fixing using suns and stars. And also tunnel construction also it is used. So the theodolite has wider major applications. The theodolite along with the compass and the chain becomes a useful in executing the works as per the drawings. So the main we have two types of theodolites. One is transit theodolite, one other is a non-transit theodolite. Transit theodolite is a theodolite where you can rotate the telescope 180 degrees along the vertical plane, and non-transit theodolite is one which cannot be revolved in one. It is in the vertical plane. So all the tears majorly or transit theodolite in which the telescope rotates 180 degrees in the vertical plane. And based upon the angles, based upon the vernier, it is divided categories into three types: uh, vernier theodolite, optical theodolite, and electronic theodolite. So the other theodolites are not that much of use. So electronic theodolite directly we can get the values. Optical theodolite is something where you able to find out the upper reading, lower reading, and then you can find the horizontal distances and vertical distance. Basically, we call it as a tachymeter. And then we have a vernier theodolite, which uses the vernier scales. So the main components of the theodolites are given here. So the leveling head, then we have lower plate, then we have upper plate, then we have standard A frame, then we have a T frame or index part, then we have plate levels and telescope. So the instruments is set up, temperature adjustments are done. So we have level head, the lower plate and upper plates. So the lower plates are upper plates plays a major role in finding out the angles between 2 points. So the basic definitions of or theolite or line of collimation is a line which passes through the crosshairs of the eyepiece and the optical center of the objective and its continuation. So what does that exactly mean? This is the line of sight. The line of sight is the line, imaginary line, which joins with the center of the objective and to the eyepiece and its extension. This is called as a line of sight or line of collimation. Then this is horizontal angle, then this is vertical angle. These are different. Many of the students believe that this horizontal angle and line of sight are same, but it's not true. Line of sight is different and horizontal line is different. Line of sight or line of collimation is line joining the center of the object and eye plane or eyepiece and its continuation. So the horizontal angle is the line perpendicular to the line of collimation. So By technical definition, we can put it in this way. So it is a line joining or perpendicular to the line of collimation is called as a transverse line axis or horizontal axis. Then we do have this another line vertical axis which passes through the center of your telescope and the center of upper plate and the lower plate and its continuation. So this normally should pass with the um, ground point. So that's the main difference, right? Then we have transitive, the process of turning the telescope in the vertical plane. If you are rotating the telescope in the vertical plane, then it's called as a transitive. If they're rotating the telescope in a horizontal plane in vertical axis, then it is called as a swing. If right side direction is called, then it's a right swing. If left swing is called, it's a left swing. If the vertical or the vertical circle, this is the vertical circle, right? If the vertical circle has the graduations or the readings in vertical axis, if the vertical circle is toward the left side, then it is called as a face left observation. If the vertical side is towards the face right, then it's called a face observations. So then we go into the adjustments. What are the adjustments of the theolite? We have two types. One is temporary adjustments and one is permanent adjustments. Temporary adjustments we have discussed in so many times, but we did not discuss the permanent adjustments. So permanent adjustments are the adjustments of plate level, then a line of collimation is good or not, whether you can be it is visible or not, we check. Then the telescope level we check, which means vertical is circle is vertically it is level or not. Then vertical circle index adjustments, whether you can see the readings or not. So these are the permanent adjustments with normal too. So temporal adjustments like we discussed, there are only 3 points: the setting up a tail light over the station, then leveling, then elimination of parallax. Parallax is nothing but when you focus a point, the direct vision of crosshairs, the focusing of the object bringing to the center exactly is called the elimination of parallax. So, if you want to find out the angle between A, B, C, then let us say these are the points A and B and C. If you want to find out the angle this, then this is called as deflection angle. The outer direction. Outer angle is called as AP, this is called as internal angle. So if you want to find out the angle, the instrument is set up at A, then a lower clamp is fixed, then upper clamp is loosened, then if you turn the telescope clockwise direction, then it starts rotating, give the angle. Then until the C is matched, then you can see the angle in the lower plate and the values are written there. So like this we can measure any angles ABC. In the similar we can also find out the vertical angles. In horizontal angles we have the readings from 0 to 360 like it was shown here. Whereas in vertical angle we do have only from 0 to 90 degrees. So if you want to find out the angle of AOB, normally it is done if you wanted to have the building's height or the tower height or the how much height the transmission line is there. So the with setup a theolite which is uh, a, uh, from the base we can access the instrument, so we can find out the distance from B to O. So then the instrument is set up at O level properly, centered properly. Then we set CD, whereas the CD are the verniers, and vertical horizontal circuit we have AB. The CD verniers are set to 0, 0. Then we sight to the point A. Then we sight to point B, and we write down the angles and record it. So it's very simple to find out the vertical angles rather than horizontal angles. So the methodology which we normally follow in theology is traversing, and we have three types of traversing. One is include angle method, another is deflection angle method, next fast angle method. So include angle method we find all the internal angles And with reflection angle is like I said, if you extend this AE line, the resultant angle is called as deflection angle. And if you extend this ED line, the resultant from D to C is the deflection angle. And the fast angle is we make use of the magnetic bearing. We approximately set up one point reference to the north, and immediately we find out the angle to it. That is called as a magnetic bearing or a fast angle methods. So the errors in the theory can be categorized into three types: instrumental errors, personal errors, natural errors. Closing error is the error when we get all the calculations done. So the instrumental errors can be categorized if the plate bubble is not adjusted properly, or the line of collimation is not perpendicular to the horizontal angles, or the horizontal angle is not perpendicular to vertical. There are three lines. So three lines, if they are not perpendicular to each other, then normally that is called as the instrumental error. You have to give to the manufacturer and get it job done. So that's called calibration. We have to calibrate the instrument well. So this is to be normally done every year if it is institution purpose. But if it is for a execution purpose, like site execution of buildings or roads or everything, then we have to calibrate the instrument every 6 months because we have some kind of errors in the instrument. Then you may be getting eccentricity in axes. So with the usage or the focusing screw, you may be getting a chances of getting errors. So then the graduations may not be even. These can be seen when you use your instrument in high temperatures or low temperatures. When you have these frequent changes in the temperatures where your locality is, then graduations may change. So the personal errors are not normally not noting down the error in focusing. These are all personal errors, and maybe getting disturbed with the assistance. All those comes. So natural errors, like I said, the high temperature causes irregular refractions in the inside of the telescope, and high winds also vibration in the instrument. This may also lead to the wrong noting on the wrong readings. So if you have A, B, C, D points, and D, A should be closed. So if you want to have a closed traverse, but due to some error, the A is at now A dash. So the from A1 to A is called as a closing error, and can be calculated if you know the all latitudes of all lines, and if you know all the departures of the lines, then the summation of latitudes and the summation of departures from these two, we can calculate the closing error given from this equation. So the permissible the relative closing error can be calculated, possible angle error you can calculate from this. So this is the formula. When you have the coordinates of each and every point, you can also find out the area of it. Thank you for watching, and uh, we'll discuss more about the area calculations in the next module. Thank you.